And about the next speaker, John. John is going to talk on the topic of developing Azure Machine Learning solutions locally. And John is a Microsoft MVP on data platform from Philippines, and he is also means data engineer at IBM. So yeah, over to you, John. Thank you.
Awesome. Hello, everyone. It's nice to be here. My name is JP. I'm a Microsoft MVP for AI. And today we'll talk about developing Azure ML solutions locally. Uh, so I'd expect to some extent that people are familiar with Azure ML, but that's fine. Like we'll you know take a look at it for a bit. So firstly, if you're not familiar with Azure, and I assume people are, Azure is Microsoft cloud platform. So basically, like if you want to rent, if you want to rent resources, like if you don't want to, because it's to some extent costly, right? If you have if you want to start building something that people would want to use, and then it's on premises, you have to buy powerful machines. So it's sometimes it's better, actually most of the time it's better to just rent. So if you monitor or like project your costs versus your costs you with on premises machines, and then using the cloud, it's actually a bit cheaper, right? So yeah, so if you want to use uh to rent machines on the cloud, Azure is definitely a great choice. So Azure is Microsoft's cloud platform now. So the topic is deploying Azure machine learning models locally, or developing them locally rather. And then so basically, what is machine learning is next, right? So machine learning allows you to make a machine do something without being explicitly told how to. So basically, usually when we program, right, we think of the rules that will come into the program. So we need to write the rules, like what makes a person successful, for example, or what makes this house expensive, or what makes an apple, what makes a hot dog, or not a hot dog, right? So those kinds of things. But with machine learning, what instead of saying that a hot dog is cylindrical and is red, what if it's a pale hot dog and it's like brown, not red? So is it still a hot dog, right? So what we do instead is we let the machine figure it out by itself, instead of telling it explicitly that this is what makes a hot dog, like what makes a chair, what makes a table. Like if a table has four legs, is it a chair and you can sit on it? So stuff like that. So instead of being explicitly how to told how to do something, we let the machine learn it by itself, given examples, given experience on it, right? So it tries to figure out. So learning algorithms are what we use to actually help the machine learn from those examples and do things without being explicitly told how to. Yeah, so I think this session will be quick. All right. So next then is combining the two words. What is Azure Machine Learning? So in a sense, right, Azure ML is Microsoft's like premier solution if you want to build custom models. Uh, well, for example, we have cognitive services that are already pre-built, and then we also have custom vision APIs, for example, and custom translator APIs, which allows us to create custom models as well. But if you want to create something that does not fall into those categories, something that's entirely new, or very specific to your use case that cannot be handled by the cognitive services, then Azure ML is your best bet. Why? Because it handles the whole end-to-end flow of the data of your model, from data up until to people use it in production. So that whole shebang, right, from end to end. So that's what Azure ML helps you deal with, right? Because usually, if like in the old, no, and not that old, but in the olden days, um, what you do is you create a model. Once upon a time, I did something like this. So, like, I I pulled a facial recognition model and then like wrapped it. I still had to wrap it in a GraphQL API and then deploy it. So that's usually what we do. Like before, we need to wrap it in an API, and then we still have to figure out like what are we going to expose in that API. For in GraphQL, it's easier because GraphQL. Um, and then but if you want to even make it even more scalable, right? So what you would just put into containers maybe, and then so you build first your application that's going to wrap your API, your model, and then put it into containers, and then scale it out using Kubernetes or Docker Swarm or something, right? So this whole process, it's complicated, but with Azure ML, it makes the whole thing easier, and it's in the cloud, right? So here are a few things that Azure ML can do. First is you can manage your data, so you can use multiple sources of your data. Like you can upload data from local, then you can reference web files from the web, or use something from a data store that you've defined. Like you can have a blob store that's been registered in Azure ML, and then you can use that. And then you can also version your data sets. And these what happens is you can go through you can pick the version that you want to deal with, and then if you want to update that data set, you can always just add more data to it, and then say that this is version 2 or 3 or something, right? And then we can build data pipelines. So it's not just so you can build one of the best things, because Azure ML currently, the Azure ML service integrated a bunch of stuff that weren't there before. So now the Azure ML Studio is a whole different thing from the old Azure ML Studio, which was a purely visual based drag and drop tool for developing machine learning models. But now it's not only limited to just visual. You can also do code based if it's something that is not, if you want to more control, and if it's something that's not supported by the visual pipeline. But again, um, given the modules that's available with the visual pipeline, I'd say that you know you can do almost everything in the visual pipeline. Because you can write R scripts there, you can write Python scripts there. You can even like have a module that will build the model itself in like with custom code. So if you want to do visual, you can go visual. If you want to go code based, you can go code based. Before there was a basic and enterprise SKUs available, and now they don't. So if you're going to use ML, everything's already available, even the visual ones, right? So yeah, you can build machine learning models visually. You can drag and drop, uh, the whole pipeline, and then automated ML, which is also to some extent visual. So you can upload your data, and then it will the AutoML service will figure out what's the best way to deal with your data to achieve your results. So you don't have to think about. Usually, you still have to think about the parameters that are the hyperparameters that will go into your algorithm. But with automated ML, it does it for you. It's basically ML for ML. So it's AutoML, right? ML squared. So and then deploy models in a few clicks. So what happens is when you create your pipeline, right, you can just hit like publish, and then it becomes you can pick if you want to work with it in batch, or it becomes a real time pipeline uh that can be requested. And yeah, assuming you have the keys for it anyway. So yeah, so in a few clicks, it can be deployed in powerful and scalable compute. Like for example, you can deploy it to Azure Kubernetes Service, so that if there's a lot of traffic going on, it will auto scale. So you don't have to worry about scaling anymore. And if you can set it to like the minimum 0 nodes, if nobody's really using your application, it will scale down to 0. So that's one of the great things. And then easily log and track your experiments. So you'll be able to see the if you don't use the visual ones, if you use the code based ones, you can like do print statements and it will appear in the logs in the cloud. And then finally, you're able to work locally with Azure ML. So you're not constrained with just selecting the compute in the cloud, but you can also use your own computer for processing. So with yeah, one of the biggest advantages of cloud is you can like provision powerful machines in for just a few hours and then you're done, right? So that's one advantage. So that's really a great advantage of the cloud. So you can just run compute for a few hours there. But if you have a powerful computer and if you have some constraints, maybe you can still try to work locally, even though you're already connected to that to the Azure workspace, to your so even if you already have that pipeline ready, you can still work locally. But this is to some extent because this still needs to some extent some internet, and then there are limitations. But let's take a look at it. So why would we consider Azure ML development local? So first is faster code iteration speed. So what happens is instead of uploading it to the cloud, instead of waiting for it to run in the cloud, you can just run it immediately on your machine. So you just do the initial notification to Azure ML that hey, I'm running this experiment, but then I'm going to run it local. And when I'm done, I'll tell you. Yeah. So and then another good thing about this is if you want to stop, you can stop and then start again. Because it's local. You can just hit Control C or something, or if you have your deployment local, you can just refresh it, and then you don't in the cloud it's more involved than that, and it's slower. So if you want to like speed up your development process, you can it's better to do it locally, except if you're training really heavy models. So that's one different thing. And then almost no compute cost because you're running on your computer, on your own compute. So you're not charged with with the compute on the cloud. So if you have a powerful computer with GPUs and stuff, you can use that instead. And then finally, you still are able to use the features like logging and model tracking. So because to some extent you're still using the internet, but for the training and deployment you use it locally. You do it locally. So yeah, so the things that can be done with Azure ML locally is one, model training, and two, model deployment. So first, model training, you can specify your compute target to be local. So alternatively, you can instantiate the class, a compute target class, and use that as sorry, I think I got kicked out of the share. Wait, give me a sec. Right. Okay. I think I'm sharing again. Okay. Yeah. So compute target local. So you can specify that, and then for deployment, you have for the cloud. If you want to deploy in the cloud, you can use the ACI web service or AKS web service. But for local, well, the name local web service, you use that. So once you specify that as your deployment config, once you specify that, when you deploy your model, it runs well, locally. Okay, so let's take a look at how this actually works. Now I'll go on over to uh sorry, let's go on over to my terminal, because quick note, when I worked with this, when I worked with local deployment, especially deployment for Azure ML, what happens is I get issues on a CentOS based device, or machines, or Red Hat based machines. So Red Hat and CentOS machines. So I have problems with those. So it works on a Mac and on Ubuntu. So that's what I've tried. So I'm using I have a VM in here. I have a VM in here set up, and I'm already SSH in. Uh, I'm using this because my internet's slow. Because the first thing that's going to happen when you do these deployments is it downloads Docker images. Why? Because this is how they make it flexible. They use the put the applications, the models inside of these containers that they generate themselves. Even with the same with the deployment and the training, so they put it inside those containers and they run. So it would require an initial download, but after that you don't need to, you don't need to do that anymore. Especially for your deployment, if it's already running, you can just reload the service. Anyway, so what we can do is check out. Uh, so I have a work folder in here. So I have data in this folder. So you can check that out. Less data, diabetes. So I have a diabetes data set, standard. So if you take a look at this, we have on the top patient ID, pregnancies. So these are the headers, right? Plasma glucose, diastolic, blood pressure, triceps thickness, serum, insulin, BMI, diabetes pedigree, age, and are you diabetic or not? So it's a 0 or 1, true or false. So this data is exactly that. So what we want to know is, given some data like are you pregnant? How many pregnancies have you had, or how much your glucose is, and your diastolic blood pressure and stuff like that. Are you diabetic or not? So yeah, it will try to predict that, right? So that's what we are going to try. So the first thing, so we have all this stuff here. We already have our scripts, right? But first we need a machine learning workspace. That's the first thing we need. Is it? Oh no, sorry. Need to. It's already here. But so this is my. So we have. So if you want to create a machine learning workspace, you can just go to. Sorry, let's go back. Create a resource. And then hit machine learning. No time. Yeah. Yeah. So machine learning. So when you hit that, it's really quick. I mean, like, configuring it's really quick. So you just hit create, and then you just have to fill up a bunch of stuff like resource group and subscriptions, and then you're basically done. There's it will automatically like create a key vault, a storage account, what else? Application insights. So it will create those automatically, and then and then also your actual, the machine learning studio. So it will provision those. Yeah, but technically you can also do them separately and just connect them as you create, but that's more programmatic. You can't really do that here in the Azure portal, right? And then, sorry about that. So now we have, let's visit studio. Okay, let's just go to. So if you already have a workspace, you have a button there. Shouldn't have closed that. right? So I've called it working, because it should work. Demo gods, come on. So you can hit Launch Studio here, or you can hit this one, so whichever you want, and then it will open up the studio. And ta-da! So again, so over here on the left, we have a bunch of stuff choices. So you can pick if you want notebooks or ML designer, and what's not there is you can develop locally, which we'll do. And then you can see that I have a bunch of runs in here. So even though I'm running locally, it still submits the results to the cloud. So you can take a look at the logs of if there's something wrong, right? So so we're here. So we have taken a look at our data. So let's take a look at our script first. So our script is the actual the script is the actual training script. So you can take a look at this. This is just the usual scikit-learn stuff. So here we're usually if you're developing in the cloud, this would be from a data store, but or like pulling a data set, but we're doing it locally. So I'm specifying that I'm getting all the CSVs inside the data folder, and then we're just separating the features from the labels in here, and then train test split with the 730 split, and then so run.log. So this one, so in here we're getting run is equal to run.get context, and this so when we get into run log in here, so what happens is this will become part of the logs when we open up in the cloud, or even after we do the training, we can actually check out those logs. So this script is usually submitted to the cloud normally, but in our case it will be run locally, but the results will be also sent to the cloud along with the model if you've registered it. So the usual stuff, accuracy, area under the curve, and then we're dumping the model that we generated. Right. So that's basically it. But this will and then run complete. So next is we'll check out demo.py. So this one is the actual. So what's great about Azure ML is you can actually decouple your actual script and how you deal with that script, like the configurations of running that script or deploying it. You can separate that. So first things first, I'm creating an environment. So an environment here, it will specify we're specifying user managed dependencies false. So this means that we don't need to manage the dependencies ourselves. So what would happen is sometimes you would install conda to install everything, but so in this case we don't want to do that. We won't. And then end.docker enabled is true, meaning we'll be dealing with Docker images. So it will download a Docker image that will contain all these libraries in here. Okay. So, and then in here we're just configuring the script. So we're passing in the reg rate, the regularization rate, and then in here is the important part. We're specifying the compute target to be local. Okay, and then after that, we'll in here we're going to submit the experiment, and then it will actually run locally. It will just say to Azure ML that, hey, we're done. But then it will run locally. We've started, and then we can do locally. And then next is we are registering the model because we're using it. We're going to use it, and then in here, another important part, this is just, give it a space. Code looks horrible. Sorry about that. So we have inference config in here, and we're specifying the local web service, right? As we talked about earlier. And then we're specifying the port. If you do not specify this, it will pick a random port that's open, and it will you will just see what the port is. And then here we'll see that we're already deploying the model. And then we're specifying the inference config and the deployment config. So for the inference config, you need to specify the scoring script, like how it will infer the answer given given the model and the data. So how do you connect those two? Right, that's the scoring script. Right. So then after that, you can you can I'm printing in here the state of the service. Usually it's running when you're done, and then Swagger URI would be so that we can see what the shape of the data is in our endpoint, and then for the scoring URI, what the actual endpoint is. Okay, so just blaze through this, and then you can just maybe just ask questions later. Right. So let's run this demo.py. So there we go. So it's starting the run. So yeah, we're already running the experiment. So we can take a look at this, right? Oops, there we go. Let's copy this and move here. We can take a look at it. So it will just say it started, but because it's already running on local, so it doesn't know what's happening yet. Yeah, well, it finished quickly. So again, you saw that we had our run.logs, right? So we can see them here as metrics. So we can see the area under the curve and the accuracy on the UI. So this is actually very helpful. Instead of digging out logs and just writing them manually, like this model performed like this, you can check it all out. Yeah, in here, right in the UI. But the training happened locally. So if you take a look at this, it already finished, and then it already registered the model, and now it's deploying. Oh, it's creating a new. Okay, great. I don't think this will be. I don't think this will take long. And after that, you can just reload and reload the service if you have changes in your, for example, in your score script. And also in here, so you have your model. You can just download your model, and since we've registered that, we can take a look at the models tab, and yeah, so many versions. Right, yeah. So let's go back to experiments. There we go. So it's done. So we have our swagger.json and our, I think I've opened it already to 8891. So I think I can open this. Yeah, no, I don't think it's loaded yet. But okay, let's just move on to score. So I happen to know what this would actually look like. So let's open insomnia. People with no sleep. So we're going to query it now. So we have deployed the model to our local Docker container. This is actually pretty quick. There we go. So yeah, okay. So I've already set it in here, but we can change this. So we can hit this and send. So we're getting 0. Let's actually try something else from the data to see. Let's find a 1 result. Our accuracy is around 0.7 70%. So it's not that good. Let's copy this. Oh no, we don't need to include 1, right? Yeah, we don't. Copy these. Let's see. And then let's put those in here. See, it should be 1, I hope. Yeah, there we go. It's 1. So given these values, the person is diabetic. The one earlier was 0, so the person wasn't diabetic given his or her data. Right.
சாமி ஒழுங்கா கும்பிட்டா பரவாயில்லையா?
Hello.
Yeah, sorry for trouble. I think. Yeah.
Right. So yeah. So we've deployed that and we've actually queried it in this core script. So that's basically it. So let's go back to. I'm just gonna exit this, and we have one more. No, I think I lost it. I mean, that's fine. Right. So next is RML with ML.NET. Oops, don't need that. So one last thing that you can do locally. This isn't really related to Azure ML, but this is something that you can do locally with if you have .NET installed and you have installed the ML.NET CLI. You can use this. I think they've already changed. So ML.NET. Yeah, I think this should be fine. I've lost the command for it. Let's take a look at that. So they actually update really fast. Anyway, so this is the last thing that we'll take a look at. So you can do AutoML in the Azure cloud, but you can also do AutoML locally. But there are still limitations to this. Like in the AutoML in Azure, in the Azure cloud, you can have customizations. Like what algorithms do you want to skip? Like what pre-processing steps do you want to skip? Like those kinds of things. As far as I know, this doesn't have those. So in here, we have, I just run that, but then cancel it real quick. We can take a look at the Yelp labeled text. So what we can see here is it's a tab separated file. So we have the sentiments, right? So, wow, love this place. And then it's a 1, it's a positive. And crust is not good, it's 0, it's negative. So, just Yelp reviews. So we want to figure out, like, given a particular piece of text, what is the sentiment of it. So we can train this actually locally using the ML.NET CLI. So we can run again this. Let's set this to 100, just to make it select better models. And then okay, so it will start running. So if you can see, it's already started training, and then it will the algorithms that it selects will actually pop up. So yeah, there we go. One average perceptron OVA with an accuracy of 0.821, 82%. So it will keep figuring out. It will keep trying out different algorithms, and then select the best one. So yeah, it's good. Just let it finish. 8 seconds. Actually, can't wait anymore. Just keep it to 10. 10. Let's run it 10 seconds. Actually, like the model for this scenario, even if it's for just 10 seconds, you have a 81% accuracy. Not bad, right? And then one of the best things here is that after you've trained the model, it will generate a sample project so that you know how to use that model in a project. But then again, it still doesn't beat the local deployment of Azure ML, but it's already packaged into an API and packaged into a container, and then also the cloud deployment is still better because you can deploy to Azure Kubernetes Service. So yeah, so that's the last thing that we'll do. So so it generated a sample classification. Project. So we have a console project in here, C# console project that already uses our model in here, right? So I think that's it. There we go. I think I just need to, it's not going down. There we go. Just keep it open like that. So just check out this feedback form for feedback for this session. But do we have any questions?
Hi guys. If you have any questions, so you can use raise hand feature and can ask. I can unmute you, and then you can ask any questions if you have. Hi, Jon. I have one question here. It's like, how we can do the setup in a Docker container. Suppose because I don't want to use my local machine. I just want to set up this whole in Docker container. So is there any way or documents, or so I can just go through for that?
So you want to run this whole thing in a Docker container?
Yeah.
Something like that. I don't think you can do that because it's a double virtualization. It's gonna do Docker inside Docker, right? So yeah. I don't think it's gonna happen.
Oh, okay. Okay, sure. No, thanks.
Yeah, but if you don't want to use Azure ML, you can definitely use Docker containers.
Yeah, that's what I was thinking. Because it's a kind of local setup, right? So
yeah.
For local setup, if we can use the Docker, and then we can.
Yeah, definitely, right? So we have for example Jupyter Docker containers, Jupyter Docker stacks.
Yeah.
So you can just pull one of those and then build on top of it.
Okay.
So that's a possibility. Like you have a bunch of you have a lot of options, like Spark based ones, TensorFlow based ones, ones that have everything. Like they even have an R image. So I think you can build off of this. But the thing is, if you want it to be flexible, right? I think Azure ML Local is a great choice because you can specify the exact dependencies that you need, and it will generate the image for you, and then that image you can just use that image because it's already on your local.
Sure. Okay, thank you so much. Yeah.
Hi John. Yeah, this is Aru here. Just want to understand something. I'm not into machine learning by any inch. I have not learned anything. Just want to understand that you showed about how to use Docker and experiment and all. Is it any option that we can use the machine learning on premises rather than cloud?
Well, yes. So we have, well, firstly, the actual stuff that Azure supports is that they have actual support would be the cognitive services. Like they have cognitive service containers. So like that's a legit thing. You just have to sign up, and then you can have those containers in your on-prem. So that's one thing. And also one other thing would be Azure Iot Edge. So that's another thing. That's still technically on-prem. And then what else? Technically, you can for your, because you're getting these models down, right? If we take a look at this, so you have models here, right? And it even generates, like if you have that run.download file, you can download the model yourself to your local. These are actually let me just open one. So you can download these, and then these models can be used by ML.net. So basically, you can just deploy your ML.net application with this model, into your, in your local, in your on-prem Kubernetes
On-premise
cluster, for example.
environment. Okay,
Yeah,
okay.
exactly.
Which means it's possible to have some machine learning, not into cloud, but also doing on-premises itself.
Yeah, exactly. So
Okay.
an alternative to, like, developing on the cloud, it's instead developing on the local machines, is would develop on the cloud, where they have super powerful machines,
Yes.
and then download the model and just deploy it into your fleet in your on-prem environment.
Yeah, I asked this question because one of the customers had completely against cloud, and they want to have some machine learning thing and all.
Right.
And I was like, completely no idea, because we never work on the on premises as much. So I thought, like, I can get some insights from you that how is it possible to do machine learning in that way?
Yeah, that's definitely possible.
Okay, thanks.
Thank you so much, John. Really nice session. Hi guys, if you have any questions, so you can raise your hand and you can ask. We can unmute you and you can ask. Let me share my slide.